Hello students, welcome to the physics class with Sujit sir. Here, today we are going to start first chapter of 12th physics, electrostatics. So, the chapter name is electrostatics. From this name, we can understand that we are going to study about electrostatics, means electric charge at rest. Electric charge at rest. So, what is electrostatics? It is the branch of physics which deals with the study of charge at rest. Study of charge at rest. So, if we are going to study about a charge, various properties and details about the charge which is at rest, then it will belongs to the chapter electrostatics. Okay, so to know about the details of electrostatics, there are two charges, elementary charges. There are two elementary charges, electron and proton. What are the two elementary charges? Electron and proton. If we denote E minus, then you can understand it as an electron. Okay. And if we denote only E or E plus, then it will be proton. So, electron and proton are two elementary charges and the unit of charge is coulomb. What is the unit of charge? Unit of charge is coulomb. C-O-U-L-O-M-B. Coulomb is the unit of charge. It is electron and E plus is proton. The charge of an electron is 1.6 into 10 to the power minus 19 coulomb. And the charge of proton is 1.6 into 10 to the power minus 19 coulomb. Coulomb is the unit of charge. These are two elementary charges. Electron and proton are two elementary charges and their charge is 1.6 into 10 to the power minus 19 coulomb. But in case of electron, we have to put negative sign, as electron is a negatively charged particle and proton is a positively charged particle. So all elements around us, every object around us made up of an electron. We know about the atom. Okay. Every particle around us are made up of atom. So atom is our fundamental particle. These are our elementary particle. Atom is the fundamental particle and these are electron, proton are elementary particle and their charges are equal but opposite. This one is negative and this one is positive. So if every object consists of atom and atom consists of electron, proton and neutron. Atom consists of electron, proton and neutron. So, the constituent particle like electron, proton and neutron, out of these three electron, proton and neutron, only electron and proton has charge, that is 1.6 into 10 to the minus 19 coulomb. But neutron does not have any charge, that is a neutral object, that is a neutral particle. Okay. So, if an object consists of electron, proton and neutron, then what will happen? Every atom or every object around us are made up of electron, proton and neutron. Yes or no? That means all charges have electric charges. All objects have electric charges. Now, come to the point that the object, just like this pen, just like this marker. Okay. This marker consists of electron, proton and neutron. Electron, proton and neutron. Electron has 1.6 minus 1.6 into 10 to the minus 19 coulomb. Proton has 1.6 into 10 to the minus 19 coulomb. And neutron has no charge. Okay. So, let 10 number of electron and 10 number of proton is present in this marker. 10 number of electron, 10 E plus 10 E minus plus 10 E plus. Okay. It consists of 10 electrons and 10 protons. So what is the total charge of this pen? What is the total charge of this pen? We can take 10 as common, and what is the charge of an electron? Minus 1.6 into 10 to the power minus 19 coulomb, plus what is the charge of proton? 1.6 into 10 to the power minus 19 coulomb. So what is the total charge of this marker? This will be minus 1.6 into 10 to the power minus 19 plus 1.6 into 10 to the power minus 19. That will be 0. These two will cancel each other. So the total charge of this marker is 0. That's why this marker is called as neutral object. So what is neutral object? The objects which have equal number of electron and proton are called neutral objects. Equal number means here 10 electron and 10 protons are present. That's why this is a neutral object, because the total charge becomes 0. The total charge becomes 0. Similarly, all objects around us are neutral because every object has equal number of electron and proton. So all objects are neutral. Okay, getting my points? So now we are going to discuss about the properties of charge. Properties of charge. There are various properties of charge. So I am going to discuss only about the important properties of the charges. Okay, first properties. So there are various properties of electric charges. So first property is like charges repel each other and opposite charges attract each other. What does that mean? If a charge, there are two types of charge, positive charge and negative charge, and the unit of charge is coulomb, and there are two elementary charges, electron and proton. What is the charge of these electron and protons? 1.6 into 10 to the power minus 19 coulomb. But proton has positive charge and electron has negative charge. So there are two types of charges, positive and negative. Suppose we consider two charges, positive charges. We consider two positive charges. These two charges are like charges, are similar charges. According to the first property of electric charges, similar charges repel each other. Repel means they will there will be a repulsive force between them. Okay, so first property is similar charges repel each other. Similar charges repel each other. But dissimilar charges. Dissimilar means if one will be positive charge, then another one will be negative charge. Positive and negative, opposite charges. But opposite charges attract each other. But opposite charges attract each other. This one attract each other. This one is the first property. Then what is the second property of electric charges? Second property is conservation of charge. Second property is conservation of charge. Conservation of charge. Just like conservation of energy, you can describe as what is conservation of energy. In the 11th class we have studied that what is conservation of energy. Energy can neither be created nor be destroyed, but it can be transformed from one form to another form. In this similar manner, we can define the conservation of charge. Here, we can say charge can neither be created nor be destroyed, but it can be transferred from one object to another object. This is the simple definition of conservation of charge. So, charge can neither be created created nor be destroyed, but it can be transferred from one object to another. In other words, we can say in an isolated system the total charge always remains constant. What does that mean? In an isolated system means if we consider a system, that means in that system we can consider more than one object or one charge, okay, but that is isolated from its environment, which do not have any effect on that system, then that will be called as isolated system. Isolated system means, suppose I want to study about few charges which are on this whiteboard. Okay, suppose I want to study about three charges. Okay, 1, 2, 3, A, B, and C. And let the charge of A is 3 coulomb, and B is 2 coulomb, and C is 1 coulomb. Okay, charge of A is 3 coulomb, B is 2 coulomb, and C is 1 coulomb. If in this system these are isolated from its environment and these charges do not have any effect from its outside. Okay, so what will happen? According to conservation of charge, in this isolated system, the total charge always remains constant. Means in this system, my total charge has 3 plus 2 plus 1, 3 plus 2, 5 plus 1, 6 coulomb. But if it is connected through a wire, then what will happen? Suppose 1 coulomb of charge is transferred to this object B. 1 coulomb of charge from A is transferred to object B. Then what will happen? This will be 2 coulomb and this will be 2 coulomb, and this one will be 3 coulomb. So the total charge always remains constant. It means 3 plus 2 plus 1, 6 coulomb. So the total charge always 6 coulomb. So we can say charge can neither be created nor be destroyed, but it can be transferred from one object to another object. This is the second property. Okay. Now third property is it is additive in nature. It means if a body has 3 charges located at different parts. Okay, suppose this body has different charges. Suppose at this part 3 coulomb of charge is located at this point, and 2 coulomb of charge is located at this point, and 6 coulomb of charge is located at this point of this object. Then according to the properties of electric charges, it is additive in nature. Means what is the total charge on this object? We can say directly take summation of these charges, then the result will be the total charge of this object. That means here total charge of the object is 3 coulomb plus 2 coulomb plus 6 coulomb, that is equal to 6 plus 3 9 plus 2 11 coulomb. Okay, so it is the third property of electric charges. Okay, so third property is additive in nature. Okay, then fourth property is this one is very important property. It is in this property it is called quantization of charge, or charge is quantized. Quantization of charge or charge is quantized. It means the total charge of an object on a body is equal to, okay, before going to give the mathematical form of this quantization of charge, I want to give you a symbol for charge. Okay, just like the symbol for work is W, symbol for energy is A. Similarly, the symbol that is in which charge is donated is Q. Okay, Q stands for charge. Q stands for charge. So the total charge of an object is equal to any plus or minus any. What is this? Q is total charge of an object, n is an integer, okay, or number of elementary charges. N is an integer and or number of elementary charges, and E is the charge of an elementary charge. Okay, charge of an electron or proton. Elementary charge means charge of an electron or proton. So we can define quantization of charge, or how charge is quantized. We can say the total charge of an object, the total charge of an object is equal to the integral multiple of elementary charge. The integral means number of integers. Okay, integral multiple of elementary charge. Elementary charge means electron or proton. Elementary charge. Okay. So it means the total charge of an object is equal to how much electrons or protons are present in that object. Suppose it has 5 electrons and 12 protons. Then what is the charge? According to additive nature, total charge of this object is equal to 12e plus 5e minus, means 12 minus 5 is equal to 7e. 12 minus 5 is equal to 7e. What is the value of E? E is equal to 1.6 into 10 to the power minus 19 coulomb. So we can say 7 is an integer. So 7 electrons are present. 7 E plus. This will be E plus because 12 protons and 5 electrons are present. After summation, we get 7 protons. So in this object, 7 protons are present which have charge 7e plus, means 7 into 1.6 into 10 to the power minus 19 coulomb. 7 into 1.6 into 10 to the power minus 19 coulomb. Let us solve an example of based on quantization principle, that is based on the formula Q is equal to plus or minus NE. Here Q is charge of a body, E is elementary charge, its value is 1.6 into 10 to the minus 19 coulomb, and N is number of electrons or proton present on that body. Number of electrons or proton present on that body, and it will be positive. It will be whole number. Okay, because there will be no decimal number present in a body. Okay, suppose if I am saying there are 1.5 electrons in this object, then what does that mean? It will be either 1 or 2. 1.5 means there is no sense. Okay, so it must be a whole number, not a decimal number, n. Okay, so here find the number of electrons. We have to find out the number of electrons, means n. Here it is asked to find number of electrons, means n. I have told you n means number of electrons or protons. Okay, so electrons transferred from a body to acquire 1 coulomb charge, means the charge of the body, that means Q is 1 coulomb. Q is 1 coulomb. Okay, and we know that the elementary charge is 1.6 into 10 to the power minus 19 coulomb. Okay, so here as it is given electrons, so it will be minus. Then as per the formula of quantization principle, Q is equal to plus or minus NE. So that is equal to, that implies, here we want to find out N. That's why N is equal to Q by E. That's why N is equal to Q by E. Okay. So here Q is 1 coulomb and E is 1.6 into 10 to the minus 19 coulomb. So we can write in place of Q 1 divided by 1.6 into 10 to the power minus 19 coulomb. So it will be, while solving, when I will divide 1 with 1.6, it will be 0.625. 0.625, okay, into 10 to the power plus 19. 10 to the power plus 19. I told you that this N would be a whole number. Okay, must be a whole number. But here you think about this number as decimal number. No, it is not a decimal number. While multiplying these numbers with 10 to the power 19, it will be like 625 into 10 to the power 16. 625 into 10 to the power 16 means in this body there are 625 into 10 to the power 16 number of electrons present on that body. Okay. So in this way we can solve any question based on quantization principle. Okay. Now I am going to give you a question. Can a body have a charge 12.2 into 10 to the minus 19 coulomb? You have to solve this question and it is your homework. I will answer this question in the next video and we will solve few more questions based on IIT JEE.